Hello, third graders. This is our week 13 number talk. The focus is on the multiplication strategy, doubling and halving. We call it doubling and halving. It's really about thinking about inverse operations, and whatever you do to one, you do the inverse to the other. So if you're going to multiply one number by 2, you would divide the other number by 2. If you're going to multiply one number by 3, you divide the other number by 3. If you're going to multiply one number by 4, divide the other number by 4. If you're going to multiply by 5, divide the other by 5. So as long as you do the same to both, you're keeping them consistently the same total value. But before we go any further, I'd love to have you stop the video and make an effort to solve these three on your own before you hear my example, or you hear my explanation for each example. So take the time, stop the video, give yourself a little bit of time, write out your answers off on the side, and then listen to the video, please. Okay, I'm assuming you stopped it, and now we're ready to look at it. So if we have 8 times 7, well, using the strategy is also allowing us to think it through. Well, would I want to take half of 7? Well, that's 3.5. And I don't know how efficient that is. So automatically I'm going to go ahead and double the 7. So 7 doubled is 14. So then I'm going to take half of 8. Half of 8 is 4. So then I know that 4 times 14 is the same as 8 times 7. Or we could take half of 4 is 2. Double the 14 is 28. So I know 2 times 28 is also the same as 4 times 14, which is also the same as 8 times 7. Or what's half of 2? 1. Double my 28, that is 56. So wait a second. So 8 times 7, 4 times 14, 2 times 28, 1 times 56. We know my answer to be 56. Now, like I said, if we did it the other way, and we elected to double the 8. So double 8 is 16. Half of 7, though, is 3.5. So 3.5 times 16 is the same as 8 times 7. Or we could double 16. 32. Half of 3.5 would be 1 3/4. So 32 times 1 3/4. 16 times 3.5, 8 times 7 are all the same solution. Or we could do 64 times 7/8. So all of those we know to be 56. The reality of it is, everything in red I don't see us doing because we haven't worked with fractions yet. But at the same time, we can recognize that, wait a second, all these values all represent 56 though, when multiplied together. So let's look at 16 times 14. Well, again, thinking this through, if we think about it, what's half of 14? 7. Oh, wait a second, we're stuck in the position where what's half of 7? 3.5. So I probably don't want to half 14, I probably want to double it. So what's half of 16? 8. What's 14 doubled? 28. What's half of 8? 4. What's 28 doubled? 56. What's half of 4? 2. What's 56 doubled? 112. What's half of 2? 1. What's 112 doubled? 224. Okay. Or another way to think about this is, if we want to just rewrite it, so let's go back to our 16 and 14 example, and let's go ahead and say, well, okay, what if we did work it the other way, where we said, okay, 16 doubled is 32, half of 14 is 7, and then we actually applied partial products. So we know that 7 times 30 plus 2. What's 7 times 30? 210. What's 7 times 2? 14, so we still get that final answer of 224. So we could actually merge two strategies together to make that more efficient. So we're just, instead of working with 16 and 14, we had to break it down. We said, wait a second, why don't we just work with a single digit number to a double digit number? And so we took advantage of using 32 times 7. Okay. And I don't know what happened to I'm having trouble with my iPad screen. I apologize. As you saw that skip. It might be my stylus. So let's look at 21 times 14. This is a perfect example of this situation. So if I took half of 14, that would be 7. So I could be left with 42 times 7. Well, wait a second. That actually might be nice, because then I could say, well, 40 plus 2 times 7. 7 times 40 is 280. 7 times 2 is 14. So I know my answer to be 294. And you know, there's other ways you could do it. To me, there's not a more efficient way, though, to do 21 times 14, unless maybe if you saw this, because again, it can be applied in multiple ways. Maybe you might be like, wait a second, Mr. Harrison, I know that 7 goes into 21 and 14. So what if I did this? What if I did, well, I'm going to take my 21, I'm going to take my 14, I'm going to divide 14 by 7, so that's going to give me 2. But I'm going to multiply 21 by 7. That's going to give me 147. So 147 times 2 is also, right, so I did that, 147 doubled would be 294 times 1. That's just another way to do it. So what I did was I multiplied 21 by 7, I divided 14 by 7. So as long as inverse operations, as long as I'm doing the same with multiplication to one and division to the other, it works. But I think for us, let's focus on the doubling and halving for now. Okay? Hope this helped. And if you have any questions, please ask the third grade team or come track down Mr. Harrison, and be happy to help you, because I think this is a strategy that definitely helps enrich your number sense. Thank you.